So in this problem, we're told that a ball of mass m and radius r is rolling without slipping with angular velocity omega. It's going to be a sphere, which means that its moment of inertia I is going to be 2/5 mr squared. And we're asked what fraction of its kinetic energy is translational. So we know that its kinetic energy is going to be 1/2 mv squared plus 1/2 I omega squared. But we also know that since it's rolling without slipping, that the velocity is just going to be r times omega. So we can plug that in right there. So that gives us the total kinetic energy is going to be 1/2 mr squared omega squared plus 1/2 times I. So that's going to be 1/5 mr squared omega squared. So the proportion of that is translational is just going to be 1/2 out of a total of 1/2 plus 1/5, which is going to be 7/10. So the total fraction f that is translational is 1/2 over 7/10, which is 5/10 over 7/10, which is 5/7. So that's going to be the fraction of the initial kinetic energy that is translational. Now we're told that the ball begins to roll up a slope, and we're asked what maximum height h will the ball achieve before it stops moving. So now when it stops moving, it loses both translational kinetic energy and rotational kinetic energy. So we're just going to convert this entire thing into gravitational potential energy. This tells us that EI equals EF. EI is just going to be 7/10 mr squared omega squared. E final is going to be mgh. So then h is just going to be 7/10 r squared omega squared over g. So the fraction of the initial kinetic energy that's translational is going to be 5/7, and the final height that the ball will achieve will be 7/10 r squared omega squared divided by g.